Hello students. In this video I'll be discussing about the module 3, so which is on the support reaction. Okay, so in this module, so we are covering some theory part of the module 3, which is definition of beam, types of loading, types of support, types of beam. Then after that, statically determined beam, how the statically determined beam is defined, how the degree of indeterminacy can be calculated. After that, we'll take one problem to understand the concept of support reaction. Okay, start with your definition of beam. Beams or beam is a structural member which have larger length compared to their cross-sectional dimension. Uh, Generally, it is a horizontal member which is used in a roofs. You might have seen in your house a horizontal member just connected to the slab is running through this slab from one end to other end of the wall. So that is called as beam. Generally, you can see that the length is huge and the cross sectional dimension is compared with the less. So that is called as a beam. Okay. Generally, the beam is subjected to some vertical forces like loading, that will be called as action, and then the support on which the beam is rested, that support produce the reaction, so that is called as a support reaction. Okay, now types of beam. What are the different types of beam? The types of beams are following. One is simple support. A simple support is nothing but the beam is simply rested over a rigid surface, so that is called a simple support. A roller support, the beams are rested on roller support, hinge support or pin support, then fixed support. One by one we'll be discussing a brief about the different support. Start with the first support, which is simple support. Simple supports are those which exerts reaction perpendicular to the plane of support. They restrict translation of the body in one direction only, but do not restrict the rotation. As you see in a diagram, the beam is rested on two rigid surface. Okay, so these two surface will produce one reaction. That means it will restrict the movement in this direction, but it can allow the movement in a horizontal direction as well as in a rotational direction. So when you consider a simply supported beam, it has a reaction in a one direction which is vertically upward. So at A there's one reaction, at B one reaction, because the beam is supported on two supports. So that is your simply supported reaction. So the simply supported reaction will have one reaction. You should know this because during the numerical problems, this will help you to define number of reaction in the given numerical problems. So next type is your roller support. Roller support are those which exerts reaction perpendicular to the plane of support. They restrict translation of a body along one direction only, and rotation is allowed. The roller support is kind of similar to the simple support, but the difference is the beam is rested on the rigid surface, whereas in the roller support it will be rested on a roller. For example, you can see that generally you might have seen in your houses a table which is attached with a wall at the bottom, so easily you can rotate in any one direction, but you cannot take it in a vertical direction. So that is called as a roller support. Okay, so generally it has a roller on the one end, or both the supports with a roller support. The roller support also have one reaction only in a vertical direction. Now moving on to the hinge support. Hinge support are those which exerts reaction in one any direction, but from our convenient point of view, we resolve this reaction into two components. Therefore, hinge support restrict translation in both the direction as vertical as well as in a horizontal direction, but the rotation is allowed. This kind of support which restrict the movement of beam in a horizontal direction as well as in a vertical direction. It is allowed to rotate the beam. So you can see that RAY is nothing but the reaction at A in a Y direction, reaction at A X direction. If you take a resultant of that, that will be RA. Okay. Similarly on the B support. So this is the hinge support. So in hinge support, how many reactions will get? We get two reactions, which is in vertical direction as well as in a horizontal direction. Moving on to the next support, which is fixed support. Fixed supports are those which are restrict both translation and rotation of a body. Fixed supports develop an internal moment known as restrain movement to prevent the rotation of a body. So generally the fixed support is nothing but the body is or the beam is completely embedded in wall, which will not allow the movement, which will not allow the translation movement as well as rotational movement. It cannot move horizontal direction, vertical direction, and it will not allow the rotate the beam. So how many reactions we'll get? We will get three reaction. One is vertical, another one is a horizontal reaction, third is a rotational reaction. So we'll get three reaction, which is ray, rax, and ma. So these are three reactions we'll get in a fixed support. So just have we'll uh, take down the number of reaction in different supports. If I consider the simply supported, we'll get one reaction. If I consider roller support, we'll get one reaction. If I consider hinge support, we'll get two reactions. If I consider fixed support, we'll get three reactions. When we are solving the numerical problems, this will help you to identify or to denote number of reaction on a particular beam. Okay. So now moving on to the next topic, which is your types of beam. You can see the figure. These are six different beam which represents the different types of beam. Start with your first beam, which is a cantilever beam. A cantilever beam is nothing but the one end is completely fixed, other end is free. Okay, one end is fixed, other end is free. So that type of beam is called as a cantilever beam. So if I talk about the reaction acting on this, how many reaction will get? We'll get three reaction, because in one end we have uh, fixed support. Fixed support consists of three reaction. One is horizontal, vertical, and the moment. Clear? Now moving on to the second beam, which is simply supported. In this case, the beam is rested on one hinge support, other is on roller support. Okay, so uh, simply supported beam is nothing but the beam is rested on any rigid surface. It may be of a roller support or hinge support. In this case, one support is a hinge, other support is a roller. So how many reaction will get over here? We'll get three reaction, because the hinge support will produce two reaction, which is in a vertical direction, another one is horizontal direction. Similarly, the roller support will produce one reaction. So total number of reaction in a beams are three. Okay, now moving on to third type of beam, which is overhanging. Overhanging is nothing but some portion of a beam is beyond the support. It is extended beyond the support. So in this case, you can see that beyond this roller support, the beam is extended. Beyond this roller support, beam is extended. So this portion is overhang from the support. So this type of beam is called as overhang beam. Clear? So number of reactions, two roller support means we'll get two reactions. Now moving on to the your fourth type of beam, which is continuous beam. Okay, you can see that the continuous beam is nothing but the number of support reactions are more than two is called as a continuous beam. In this case, we have four number of support reactions. So if you have four support reaction, which is more than two, such a type of beam is called as continuous beam. So in this case, how many reactions will get? This is hinge support. So hinge support will produce two reaction. One is vertical, another one is horizontal, and this reaction produce one reaction. This support will produce one reaction. This support will produce one reaction. So total will be 2 plus 1 plus 1. Total will be 5 reactions. Okay. Now moving on to the next type of beam, which is fixed ended beam. That is nothing but both the end of the beam is fixed, have fixed support. So that type of beam is called as a fixed ended beam. So in this case, how many reactions will get? The fixed support have three reactions. So three on this side, three on this side. So total number of reactions in a beam will be 6. So next type of beam is cantilever, or generally it will be called as a propped cantilever. Here cantilever simply supported is written. Generally it will be called as a propped cantilever. A propped cantilever is nothing but a propped or a simple support or a roller support is provided on the free end of a beam. So it is similar to the cantilever beam, only this support is added. So this is called as a propped cantilever. So in this case, the number of reactions will be 3 plus 1, 4 reactions will be there. These are the types of beam. Now we'll move on to the next bit, which is your uh, types of loading. So you can see that there are 4 figures displaying over here. So one is concentrated load, second is uniform load, or it also called as uniformly distributed load, third one is uniformly varying load, and fourth one is applied couple or a moment. So I'll tell you the difference between all 4 forces. First we'll consider the concentrated load. A concentrated load is nothing but a point load acting on a beam is called as concentrated. That means the load will concentrating on a particular point. So that type of beam is load is called as a concentrated load. Next is uniformly varying load, or it also called as uniformly distributed load. Generally we write UDL. Okay, so in this case certain amount of load is uniformly distributed over the span. For example, W is a load and the span is L. So the W Newton per meter load is distributed over the span of L. So that is called as a uniformly distributed load. So whereas third one is uniformly varying load. Uniformly varying load is nothing but the load is gradually increasing from 0 to the specified load. So it will be in a form of a triangular loading. So the 0 and the higher end. So at this load, the load at this point or the support, the load will be 0. As we move on to the other end, so it will be maximum, which is W Newton per meter. So this is called the uniformly varying load. Now the fourth one is applied couple. Generally applied couple is nothing but the rotation or the moment is applied on a particular point. So generally when you are having this type of couple or the moment in a numerical problems, during the calculation of summation of m naught, that time only we can consider this moment during the calculation of summation of m naught or summation of any specified point. Whereas in the summation of effect in the Fy, this load or the couple will not be considered. Okay, these are the 4 different types of loading. Now we'll move on to the your conversion of your UDL and UVL into the equivalent point load, because when we are solving the numericals, the load should be in the form of your equivalent point load, so that it will be easy to calculate the support reaction. So in this case, what we are doing is we are converting UDL form into the equivalent point load. Generally, when we are calculating the support reaction, the load has to be converted into equivalent point load. So in this case, the W load is acting on a span of L. Okay. So if I want to convert that load into the equivalent point load, then the point load will be act at the center, which is nothing but L by 2 distance. If the span is L, then it will be act at the center, and the magnitude of load will be W into L. So this is the conversion of your UDL into the equivalent point load. If I consider one example which has 10 kilonewton of load per meter length, and the span is around 3 meter. So in this case, if I convert into equivalent point load, the load will act at the center, which is nothing but 1.5 meter distance. Okay, then the intensity of the load or the magnitude of the load will be 10 into 3. That is 30 kilonewton of load is acting at the center. Similarly, for UVL kind of loading, uniformly varying load. So in this case, the load can be converted into equivalent point load will be, load will act at a 1/3 distance from the right angle of a loading or highest end of loading. So from highest end of loading, the load distance will be 1/3 of L. If this is a L, then it will act at the distance of 1/3. So remaining distance will be what? 2/3 of L. And here the intensity will be, the load half into load into the span. Okay, this is the intensity. So if I consider one problem, one example of UDL, which is of 10 kilonewton at the highest side, and it has a span of 3 meters. So in this case, the equivalent point load will be, where it will act? It will act 1/3 of distance from the higher end of loading. So higher end of loading is on this side. So 1/3 of 3 will get 1 meter. So remaining will be 2 meter. And the load intensity will be half into 10 into 3, which is nothing but 15 kilonewton. Okay. So this will be the 15 kilonewton at a distance of 1 meter from the higher end, 2 meter from the from 0. This is the conversion of your UDL into equivalent point load, UL into equivalent point load. This basic is required during the numerical problems. Generally, beams or the structures are classified into two categories. One is a determinate structure and another one is an indeterminate structure. So in this case, we'll be discussing about the statically determinate beam, a determinate beam. So generally, a determinate beam is one which whose reactions are equal to or less than the number of equation of equilibrium. Then that beam is called as a statically determinate beam. So the unknown reaction can be found out by using the equation of equilibrium. That will be called as a statically determinate beam. So for example, if I consider a beam, one end is hinge, other end is roller. See, so in this case, how many reaction will get? As we have seen earlier, hinge support will produce two reaction. One is a vertical direction, another one is a horizontal direction. So I'll give this a RV, this as a RH. Similarly, a roller reaction will produce a one reaction which is vertical reaction, R. So in this case, the number of reactions are 3, whereas we know that the number of equation of equilibriums are 3, which is nothing but summation of fx equal to 0, summation of fy equal to 0, summation of m equal to 0. So the number of equations and the number of reactions are 3. So this beam is called as a statically determinate beam. This is degree of statically determinate beam. So in this case, the beam reaction and the equation of equilibriums are equal, so we'll get 0. Whereas again, one more beam we'll consider which has both the supports are hinged. So in this case, the number of reaction produced will be 4, correct? So 2 on the one side, 2 on the other side. So number of reactions are 4, whereas equation of equilibriums are 3. So ds what will get? 4 minus 3, which is 1. This is indeterminacy, or is called as it has a 1 degree of indeterminacy. Similarly, if you have the 5 reaction, then degree of indeterminacy will be 2. So like this, the statically determinate beam is defined. So for your syllabus concern, the beams or the reaction what we are calculating only for the statically determinate beam.